Tribofilaments have very good tribological properties, meaning they have a very good wear resistance and sport very low coefficients of frictions against many metals. But they don't excel in every discipline, for example, in terms of mechanical stiffness. And this is why we found a way to combine multiple materials that have different properties to receive a part that combines the best of both worlds, so to speak. In this case, we've designed a gear that is made from a carbon fiber reinforced polymer in the middle to gain a very strong and stiff part, and shows a tribofilament on the outside where the gears engage with each other to have it be wear resistant and to run efficiently with low friction. Like with every 3D print, we need a 3D model to be able to print this, but in this case we need two volume bodies, one volume body for each material that we want to print. We need to have a 3D model that has these two models with the same origin, and when we load the model into the 3D printing software, which is Ultimaker Cura in this case, we can assign one material to each volume body. There is not even that much that we have to consider when designing for multi-material printing. The only thing that we need to know is how the two materials are combined and how they connect with each other. In some cases, materials are very compatible and they melt a little bit in the area where they touch each other. But when that is not the case, we need to make sure that the materials interlock so they cannot be separated by any forces. In our blog post, we go into detail on how to design such an interface between two materials so that they cannot be separated.